All right, folks. So now we're going to be talking about the unit circle. And you may have been exposed to this already, but hear me out. There's a few things I want to show you. Some reasons why the unit circle exists. Why is it called the unit circle? If you can't remember for the life of you how to make the unit circle, I'm going to show you some patterns to this. Okay. So first of all, it's called the unit circle because we're going to assume, we're going to assume that it's all a distance of 1. So this is a circle with a radius of 1. So this is 1, that's 1, 1, 1, 1, 1, 1, 1, 1, 1. Okay? Don't worry about writing those ones. I should have told you that earlier. So that's what's called a unit circle because it's a circle where the radius is 1 regardless of where you're at. Okay? Now, as a reminder, recall that this is the x-axis and this is the y-axis. So if I'm going this way on the x-axis, we're positive, right? This way on the x-axis is negative. This way on the y-axis is positive. This way on the x-axis is negative. Okay. Now, if we focus on the first quadrant, it is called quadrant 1. You're going to notice that each point on this circle that is made by the radius and the circumference is an xy coordinate. So for example, this coordinate right here, x is 1, y is 0. And on this point up here, x is 0, y is 1. Okay? Now let me propose this to you. What if instead, you'll notice, I shouldn't have done that yet, you'll notice that the x, and what's happening is we're making triangles each time. So for example, here's a triangle, right? And then here's a triangle, and then here's a triangle. This has an xy, this has an xy, this has an xy. But you'll notice that each time we move the point along the circumference, you'll notice that the x-axis gets smaller, right? The leg, this leg of the triangle on the x-axis is getting smaller and smaller and smaller each time. And as the x gets smaller, you'll notice that the y gets bigger, it gets taller, until it gets to 1, and then it gets to an x value of 0. So what I'm going to suggest to you is the following, that the x is going to get smaller and the y will get bigger. Okay, so we had 1, 0, right? Would you be okay if I actually wrote this as square root of 4 over 2, comma, 0 over 2? And if not, well, deal with it. Because what is 0 over 2? What is the square root of 4? And if you take that answer and divide it by 2, you get 1. So technically, this is 1 and this is 0. But we said that as we go further up, the x will get smaller, right? So I'm going to propose this to you. I'm going to make these all go over 2. And the x right now is at its max at radical 4. So I'm going to count downwards, square root of 3, square root of 2, because the x is getting smaller, square root of 1, and then if you want, square root of 0. We said as the x gets smaller, the y gets bigger. So we started with square root of 0, square root of 1, square root of 2, square root of 3, square root of 4. Now at this point we can do some simplifications, right? We know that the square root of 1 is just 1. Nothing to simplify here. Square root of 1 is 1. Square root of 0 is 0. 0 divided by 2 is 0. Square root of 4 is 2, but 2 divided by 2 is 1. Okay, same thing over here, right? This becomes a 1, that becomes a 0. So notice that there isn't much to it. I mean, some of your teachers maybe have gone into great depths into doing all kinds of weird things and solving each triangle one at a time. No need for that. There's a beautiful pattern here, okay? Of course, that beautiful pattern becomes a little obfuscate when you look at the simplifications, right? Okay, but once you recognize that this is just square root of 4, square root of 3, square root of 2, square root of 1, square root of 0, and then it goes in reverse the other way, then you have a better understanding of quadrant 1. Okay, now that's quadrant 1. Quadrant 2 is going to be going down now. Okay, so if we started off, let me kind of help you out here. If we had over here square root of 0 over 2 and square root of 4 over 2, now it's going to go down, right? So the x-axis is going to get bigger, the x is going to get larger, and then the y's are going to get smaller to the point where we end up with this number over here. Okay, but we're on this side of the x-axis. The y is still positive, but the x's will be negatives. So we can go ahead and do the same pattern all over again, right? Square root of 0, square root of 1, square root of 2, square root of 3, square root of 4. And then the y is going to go down, so it'll be 3, it'll be 2, it'll be 1, it'll be 0. But all the x values will be negative, so you're going to need to go back and make this a negative, a negative, a negative, negative, and a negative. Now, of course, negative 0 doesn't affect you, so this doesn't really affect the problem. This is still going to be a 0, right? Go back and clean these up. So the square root of 1 should be regular ones. Clean this up. This will be negative 1 comma 0. Okay. What I'd like you to do is you can pause me at this point, but I'm going to suggest that you go ahead and do the same thing that I've been doing. Follow the same pattern. Keep track of your x, keep track of your y being negative or positive. And I want you to go ahead and do quadrants 3 and quadrants 4. So go ahead and take some quality time and put me on pause, fill out the rest of this thing, do quadrant 3, do quadrant 4. Pause me. All right, I want to go ahead and bring up a few things about this. So I want to focus my thoughts on quadrant 1 right now. And I want to point out the following, that these numbers represent a lot. Okay, for example, if I look at this second point, and by the way, this is 0 degrees, this is 30 degrees, this is 45, this is 60, and this is 90 degrees. So what this means, if we look at the 30-degree point, this is the ratio, right, of a few things going on here. Okay, you'll notice that this is the x value, and this is the y value. Okay, so this first one right here, this first term is going to represent cosine. So all the x values in here are going to represent cosine. And then all of the y values will represent sine. So for example, the cosine of 30 is radical 3 over 2. The sine of 30 is 1 over 2. The cosine of 0 is 1. The sine of 0 is 0. Okay. The cosine of 60 is 1/2, etc. Okay. So I want you to be able to notice that about these things. Cool. And so let me make sure that I don't want to confuse anybody, but I probably shouldn't have written those here. I probably should have written them more like over here, but I wrote them over here so you can see them better, okay? Because if I were to drop a line down and form a right triangle, this is actually the 30-degree and this is the 60-degree mark, okay? But I put them here that way we have more space to see what's going on. So just be aware that these angles that I put here do not represent these angles. They represent these angles down here that they form with the horizontal, okay? And if you're wondering what happened to the hypotenuse, well, the hypotenuse is 1, right? So if you actually do this right here is the actual literal x value, and then for the hypotenuse it would be all over 1, okay? But the reason why they come out to be fractions is because that's the way it comes out when you do the math. Okay, moving on. So if you wanted to just summarize it, this would be a great place to do that. Notice that we did For example, the cosine, we started off with radical 4 over 2, which is equal to 2 over 2 equals 1. This is radical 3 over 2, radical 2 over 2, radical 1 over 2, which is 1 over 2. And this ends up being radical 0 over 2, which is in the scheme is 0 over 2, which is 0. So you're going to fill out the other ones too, that'd be great. Keep in mind that we're usually not going to make unit circle for problems, but knowing it helps your understanding. We have the 4 quadrants, right? That they're going to go in counterclockwise direction. Go in case if you forgot. We're calling this quadrant 1 over here, quadrant 2, quadrant 3, and quadrant 4. We have a saying that all students take calculus. So all means everybody is positive. So sine is positive, cosine is positive, tangent is positive in the first quadrant. S, only sine is positive in the first quadrant. Cosine is negative, tangent is negative. In quadrant 3, it would be t, tangent would be positive, and in quadrant 4, cosine would be positive. That would make sine negative, cosine negative, sine negative, tangent negative. Okay. Some of you might be wondering, well, how do we do tangent? If you want to find tangent, if we look back at, for example, if we look back at, you could actually make another table here. That'd be a good thing to do. We could do tangent right here, right now. So for example, cosine we said was radical 3 over 2, right? And sine was probably 1 over 2. That's probably the bad one. Let's not do that one yet. Then we have radical 2 over 2, radical 2 over 2. If you want to get tangent, this might be a good left column idea. Tangent is actually sine over cosine. I'll show you many times why, but just take it for now. So that means if I go ahead and divide these two, you'll notice that the 2's cancel out, the radicals cancel out, and you end up with 1. So the tangent of 45 is 1. Okay. On 60, we got radical 3 over 2, and we got 1 over 2. If I put sine over cosine, divide these two, the 2's cancel out, and I'm left with radical 3 over 1, which is the same as radical 3. Mind you, when you put these in your calculator may not give you the exact values. I do want you to be comfortable with these exact values, and that's why I'm getting to you. But for example, radical 3 is like 1.7 something, right? Radical 2 over 2 is 0.4 something, I think. Okay. So if you're going to use a calculator, you might get decimals, but some of these problems I will require you to be able to use the actual values, okay, the exact values with radicals.